My name is Miriam Gangi. I'm in charge of communication and press office of ANFIA, Italian Association of the Automotive Industry, who is one of the 11 partners of SURE 5.0 European project. SURE 5.0 project aims to support European SMEs in advancing their digital transformation while becoming more and more resilient, sustainable, and human-centric. Let me go quickly through the agenda of today. We will start with a brief introduction about SURE 5.0 European project from Michael Zwantschko, task leader of this project from the technology cluster Silicon Alps. Then we will listen to the speech of Dr. Rudolf Pichler, one of the two esteemed experts we will host today about additive manufacturing technologies. So Dr. Pichler is from the Graz University of Technology. He's a scientist, and he's also the head of a pilot factory called the Smart Factory at TU Graz. Then we will switch to the speech of Miriam García, European Project Manager of Lortek. Lortek is a member of the Basque Research and Technology Alliance and is also a member of EIT Manufacturing, an innovation community supported by the European Institute of Innovation and Technology. EIT Manufacturing is another of the 11 partners of SURE 5.0 European project. And Lortek is also one of the service providers of this project. Then we will have in the end a Q&A session. But I have to signal that due to a small change in the agenda, if you have some questions for Dr. Pichler, you will be able to put them in the Zoom chat immediately after his speech, because at the end of this session, you will leave, since he's engaged with other activities. Normally, for the Q&A session, we will ask to wait for the end of the speeches and then write down your questions in the Zoom chat. And finally, some simple rules for the webinar. Please keep muted your microphone and keep switched off your camera in order to save band. And now I will give the floor to Michael from Silicon Alps, and enjoy the webinar.
Yes, good morning also from my side. My name is Michael Zwantschko from Silicon Alps cluster. We are a semiconductor and microelectronic cluster in the southern part of Austria, and we are part of the SURE consortium. I just want to give you a brief introduction about our project. SURE 5.0, the goal of the project is to support European SMEs in their digital transformation process to become more human-centric, sustainable, and resilient. The overall topic is Industry 5.0, which is a topic strongly pushed also by the European Union, and it aims to introduce the topics of human centricity, sustainability, and resilience in manufacturing processes. So how you can participate and what is the goal of the project and what are your benefits of. So first of all, European manufacturing SMEs are active in those three strategic industrial ecosystems are able to participate in the project. If you are an SME working in those three sectors, mobility, transport, automotive, or aerospace and defense, or electronics, then you have the chance to be part of the projects. And how you can be part of the project through everything is published on the website SURE5.0. And to be part of the project, the first step in is to go to the self-assessment tool, which is an online questionnaire where you can fill out some questions related to your organization, to your production facilities, and so on, to get a brief and quick overview about your integration and digitalization strategy related to Industry 4.0 as well as Industry 5.0. The outcome of the self-assessment is a quick report, a PDF, where you get the assessment results and some brief recommendations. And the second step then is that you can apply for the core. And part of the project, like today, are also 5.0 awareness webinars, where we are raising different topics to introduce and to give a brief overview about digital tools and what is possible to implement in your production facilities. So today you are part of such an awareness open webinar, just to raise the awareness about the topic of Industry 5.0 and our project. Within the core, you can get 10,000 euro of in-kind services, tailored services. And in the phase 2, you have the chance to apply for a cascade funding to get 50k euro for the implementation project you are aimed to implement in your organization. And then the last point, you can start your transformation process. Within the project, also technological service provider have the chance to be part of the project, as we intend, or the SMEs should, let's say, invest part of the 50k, approximately 60% of those funding of the 50k euro should be sourced to service providers in order to get technological know-how into your organization, to get the right support for your implementation of the project. And the rest of the 50k, the 40%, remains for own personnel costs, investment costs, and so on. So this is just a brief overview. And part of the project, we have also a community of practice alliance, where everybody interested in the topic of Industry 5.0, SMEs, stakeholders, universities, and so on, can be part of. And we have a LinkedIn group which is open, and you can join the group. The timeline right now of the project is that we have currently opened the second acceleration program with 3 cutoff dates in the 25th of October, 3rd of January next year, and 28th of February. We have a first come, first serve principle. And yes, this is the chance for you to be part and to apply for the project. All related information you can find on the website, or please drop us a quick email. What do we offer? I just go through quickly. In the phase 1, you get individual assessments, investment readiness support, part of training activities, social innovation and human centricity know-how, and you can be part of the community of practice alliance. Within the phase 2, where you apply for the 50k funding, then you have further access to the investment readiness support, specific training activities which were developed by our research partners in the project, further social innovation and human centricity know-how, and you have access also to the technological facilities of RTOs in order to make a proof of concept testing of your project you intend to implement in your company. And last but not least, the timeline, like mentioned, we started end of July, the second acceleration program, which is currently open till end of February next year. We have 3 cutoff dates, 25th of October, 3rd of January, and 28th of February. So, and after each cutoff, we do an evaluation of the applications, and then you get the announcement if you were selected or not, and you can start with the phase 1 program, which supports you to get ready for the application for the phase 2. And yeah, depending on which cutoff date you make the application, then you see here the timeline of the whole program. That was it briefly, and if you have questions, please do not hesitate to contact us via email. Thank you.
Thank you, Michael, for your presentation of the great advantages of being part, the benefits and the advantages of being part of SURE 5.0 project as a European SME. And also reminding us that there are some opportunities for service providers and Industry 5.0 stakeholders. So every participant of this webinar is invited to depend the matter on the project website and join us if they are interested in this topic. Now let's switch to a more scientific point of view, and let's discover the potential of lightweight design and manufacturing via 3D printing with the speech by Dr. Rudolf Pichler.
Okay, good morning, ladies and gentlemen. I'm very happy to be with you and to talk about 3D metal printing. As I want to point out from the very first time, we are dealing not only with plastic 3D printing that is quite frequently used also by private persons, but for industry, especially the metal 3D printing or the metal additive manufacturing is an important topic of the future. I'm going to share my screen. Lightweight design and manufacturing via 3D printing. Once more, my name is Rudolf Pichler. I work at the Institute of Production Engineering at Graz University of Technology in the south of Austria. So, my short agenda is the following. Simply said, what are the drivers of lightweight products? It should be quite evident and simple. Then I will talk about the principles of lightweight design. And last but not least, I will go in a short way into the so-called topology optimization. This is a way how we can come easily to such products or to such designs. If there's an important questions, you're invited to interrupt me immediately, and I will try to give you a good answer. So, as a first slide, I want to give you an introduction, and it's quite evident, I think 3D printing is definitely a future issue, yes. Lightweight design is driven by various branches, and it's not a really surprise that it's driven. If we look the development going even up to 2026, as we have got from the 3D printing trend report 2022, we see a rocketing development of these activities, and this is not only the metal 3D printing, it's of course it's plastic, it's ceramics, it's other materials, it's nearly all materials that actually are used for doing 3D printing. And the branches who are really the drivers, and they put a lot of money into it, is of course aerospace and also defense, military use, of course, once more, the aircraft industry, also medical and dental industry, automotive industry, and many others. Yes, and why is this a fact? It's no surprise again. If we have products and components with less weight in comparison to former forms of products, with less weight, we have less fuel consumptions, we have less environmental pollution, and what is also very important, we have got less running costs. To give you an example, if there in the aircraft industry, there's a component that should be suddenly made of in lightweight design via 3D printing or additive manufacturing, the aircraft industry or even the runners of airplanes, they simply make a simple calculation. They say the part itself is more expensive because this technology is not a very cheap one, but they say if we regard the whole lifetime of an airplane, it will lead to less fuel consumption and then the calculation is a good one, the return on investment is given. And that is a good driver for the development of this technology overall. Okay, so 3D printing has a lot of advantages, and it simply says we can design products. In former days, it was not possible, yes? And nowadays, it's products that show lightweight design can be even producible. I will give you a simple example. If we've got, for example, a hydraulic block, then for years and decades, it has been made and produced like this. In a hydraulic block, you need to create channels like you can see here, yes? You have the feeds in and you have the feed outs, and it was not producible in a different way than this way, yes? And what you can see, you have a lot of material you really do not know, but it's very expensive to chip it off as well. So the final stage of this product still was this like a cheese-looking part, and it was a heavy part. With the means of additive manufacturing, nowadays it is possible to have the same part with the same function in a quite different way. Either you do it on the down part, on the downside here, you do it like this. You still have a frame maybe for stiffness or however, but you have already these hollow sections that can be produced. Yes, you can cut out it very easily. Or even in a better form, you end up in this design. Yes, you can compare. In former days it looks like this, and nowadays it is possible to reduce the product to its very functions. In this case, in this very case, we can have a good balance that shows the weight reduction in this example from this to here could be by 80%. This is quite a lot, yes? Not only the lightweight is an advantage, but the way of streaming the fluids through these channels with these rectangular bows and bands causes pressure losses. And if we could do it in the design, and the stream is more like a streamline design, then we even can reduce the pressure losses by 50%, one more. And other benefits also could be created. You could apply cooling fins, special interfaces for sensors, and much more. So the advantage is really very high. The steady question is, and here is an example again from aircraft industry. This is a bracket of former days with a weight of 980 grams. With additive manufacturing design and the technology to manufacture it, you can come down by, in this case, by 64%. This is also quite a lot. The question coming up, of course, is, yes, wonderful. From the former design, blue column, we could come down weight 2/3, like you can see here, or what the numbers show here. But what about the mechanical properties? Yes, and this is quite an issue. But also here we can say, if it is made really carefully, then you can keep up the necessary stiffness, even maximum bolt force. For this case, the stress in this case is a little bit lower than half. But you can optimize, and maybe you come down with weight not that much, and you get some advantages still in the maximum stress if you need it. Yes. Overall, you can say there is, with a really good design, and we will come to the topology optimization later on, with a good design, you can optimize and create the necessary stiffness or the mechanical properties, as well as you had it in the former design, like here. Okay, so there is no excuse not to use and to work with additive manufacturing for creating lightweight design. I may point out some construction principles for doing lightweight design in the next slide, and these are only cut out 3. My first proposition, or my suggestion, would be for the constructors, for the engineers, please forget the right angle. Why was the right angle in construction so important? Remember the hydraulic block. It is simply due to the machine tools we still have, yes? Nowadays, we've got even better machines with more opportunities and possibilities, but most of the machines are still built up like this. You can drive your tools only in the X, Y, Z direction, and this leads to these rectangular constructions. But as you can see, for a new product, maybe this is this was playing around from my students and colleagues. It is possible to leave the right angle, and you really could do what you like. And this is my special suggestion. Please draw the things like you want. We call this additive thinking. Additive thinking is lose the thinking of right angles, do it as you need it and not more. Put and use material only where you use it. So next example is how to come to lightweight design. Mostly it is you work with full material. Yes, and full material doesn't have there is no need for the material for the part, because the flow of forces, it does not need maybe some inner metal work and build up. With additive manufacturing, it is possible now to work with so-called mesh structures. As you can see it here, this is a lever, and this is the side part of the seat of an airplane. Yes, with mesh structures, you get the necessary stiffness, and you with using the air and the holes in it, you come down with weight. Yes. So now one hint: don't fear that you have to construct these single connections. This is not necessary. When you work with software, you have tools within the software that propose to use different forms of meshes. So you just mark the outer borders, for example, in this case, and then you press the button with the command fill out with a certain mesh, type A, type B, type C. Means this is already a wonderful add-on tool in the software when you work. So last but not least, it's only 3. Of course, in real life, there's much more possibilities, but I want to keep it quite simple and give you an overview. What I suggest for coming to lightweight design is use topology optimization, and of course, you have to work with software. And this is a first example and draft. What is the original part and what is the end part? I will show you, maybe because I assume that you are not acquainted with topology optimization so far. I will show you, give you a brief example for this. Oh, there's one more supporting the idea with the mesh structures. One more example, really to come down with weight tremendously. This is a motor block with 5.1 kilograms. And as we remember, additive manufacturing, additive design allows for the construction engineer also to work with hollow sections, undercuts, and mesh structures. And the result in this case for this motor block, for example, is you come down even down to 1.9 kilogram, and this is due to, if I go into the inner and show up a detail, because of the mesh structures, where in former times there was full material. Yes, this is a tremendous step down where we go, and the mechanical properties, stiffnesses and strengths are of course must be the same, otherwise this part would be useless. So now we come, and I want to give you a short introduction how topology optimization works. Let's create a model bridge, not a bridge for real life, of course, because the dimensions would be too high, but maybe you've got for your playground, for your small play trains. I don't know the English word for it, but let's build a small bridge with a dimension not, let's say, not longer than 10 centimeters, as an example. What is the first step? What you do for this, of course, you use topology optimization. You cannot do it manually, of course, yes? Then you set, this is the blue dotted line here, you set the 3D design area. Means in X, Y, Z, you say the maximum where this bridge in this case could extend is dimension ABC. yes, or XYZ. So here I only have got a 2D design and a sketch here. So the next thing is that you say, yeah, more or less we have to build a bridge. I simply set a bar just to know where these forces fly around. You do not really draw this bar, but only at some position within this frame, within this blue frame, you put the reaction forces. Yes, and as we know, with a bridge, we have a fixed support, like here in 2 dimensions, even 3 dimensions. Of course, you have a second support force. You have also torques to regard. This is a torque reaction, and of course, you have the burden of the bridge, because there's vehicles going across, or simply you have any other force being put here in the middle. So as soon as you did this, you have to do, after the force is set, you also define the maximum of tensile strength. Yes, this is already in connection, because you know which materials you have to use, or you're going to use. And depending the material choice, you have to obtain a maximum of forces. So this is the beginning, and then simply said, really simply said, you press the button, yes, in this software, and there's a calculation done. There's a lot of equations, thousands of equations, and then there's done an optimization. And the output will be, and please look at issue item 2 here, you get a first draft out of the program, yes? And this draft looks like this. It's a little bit crazy and strange, because sometimes you have interruptions, there's no material, yes? But this is the consequence and the result out of the calculations. And you have to, and then the engineer comes back again and does some adaptations, and he can build up he or she can reinforce the dimensions of the principal geometries. The most important output of such a topology optimization is the allocation where forces sooner or later should flow. So you develop from this here, not even being producible, to this here, and in a third step, you're doing some smoothing, because what you can see here, there's a lot of cracks, and it's not really smooth. And as we know, as mechanical engineers, this is the beginning of a crack and is not allowed. So with manual rework, you can also, with use of the tools of software, you can smoothen this principal geometry. The more you go into FEM calculations, and before you really refine it, but this is more or less the result and the way, very roughly, how you come to a topology optimized part, in this case a bridge. I give you some examples from aerospace as well. In former times it was like this. There's a lot of metal sheets that were welded together. You created some stiffness via additional metal sheets, and you can think that this is quite heavy, and via topology optimization you end up in such a design. It's quite wonderful, because all these designs are very close to what nature is doing. Yes, if you watch, for example, the structure of a leaf, you can find quite similar designs. Yes, so this is one example. One more example. This is also what we did in our small factory. For example, gripper fingers. Yes, for robots, you need any weight reduction, and you simply do it via topology optimization. Yes, this also we did at our institute. It is part of a lightweight robot arm. In former times, it was a simple tube, and this topology optimization, the result of this was this really. It's really design. It's very lovely. Other examples you can find here, or here a lightweight reduced console. Yes. I have to add, if you have these examples, console, or even maybe this tube, the technology of metal additive manufacturing and the periphery with the software you need and so on is quite costly. Yes, you really have to consider. But especially if lightweight can reduce your fuel consumptions or you get other advantages, I could talk hours now about this, then it makes it is reasonable to go and to use this technology. This is my statement here. Okay, so the time is too short. I could talk a lot, but I want to summarize in the following. Additive manufacturing, or alias 3D printing, has got a high impact to come down in weight, and this actually in these times, this is a big contributor to the reduction of carbon dioxide. Yes, the way for lightweight design has to leave conventional paths. Yes, in doing constructions, I can only repeat, and this is what I what I tell the people in the construction department. Really, leave the right angle. Yes, do it like you think that it is necessary. Undercuts, no problem. Hollow sections, no problem. Work with meshes and so on. This is additive thinking. Topology optimization as a technique, and of course the use of software, of relevant software, is a good way to reduce material in the most appropriate way. You're very effective to come to the most appropriate design. Last but not least, additive manufacturing for metal components is not a low-cost technology. Yes, it's not. It doesn't make sense if I tell you the expenses I had, because you need a certain machine. I would have to describe the whole application with its periphery. But overall, it's not a low-cost technology. Think about to work with partners, maybe. There is a lot of machines already around. They know how to do it. You are responsible. You can do the design and then cooperate, because the manufacturing itself is a little bit tricky. Yes, it's not a plug-and-play technology. So, and with this, though it's more or less expensive, a couple of applications, I would say, can easily compensate the investment. You have to do it very carefully, but there is action fields for this technology. And once more, if you remember the first slide I brought you, this technology is rocketing. So far to my short speech about additive manufacturing and 3D or lightweight design. Sorry, and I'm still ready. I have to leave in a couple of minutes, but I'm ready for your questions now. Thank you so far.
Thank you, Dr. Pichler, for your interesting presentation, stressing some important concepts like additive thinking. I found it very interesting, and it confirmed the fact that 3D printing is really a groundbreaking technology that can revolutionize the manufacturing processes of SMEs, driving innovation, sustainability, and cost effectiveness within the industry. So if there are some questions for Dr. Pichler, this is the moment to write them down in the chat, or even speak directly if you prefer. We have a few minutes for answering your questions. Okay, we have one question. Could you please inform the latest design for lightweight?
Sorry, once more, I can read then. If I could explain the lattice design.
Lattice software.
The software, which products of software there are available? I didn't mention, is this the question, which type of software, the name of software that can be used for topology optimization? Is this the question?
Yeah.
Okay, in our case, we use from the company Alps. This is the product Inspire. But I can tell you there are many more. Nowadays, nearly each modern CAD program has add-on tools for doing such designs. Yes. If you use Dassault systems, or you have from Siemens the products, they all have in their CD programs integrated tools for doing topology optimization in a way. And they have also tools and add-ons for doing the meshes and the lattice structures. Once more, you do not have to construct or design the single meshes. You simply you mark the borders and you say, please fill out this space with a lattice or a mesh structure of type A, B, C, D. You have a couple of proposals. Did this answer the question?
I think so.
Otherwise, if there are further questions and maybe the people are too shy, the people should know my mail address. Simply send me an email. I will respond immediately.
Okay.
Okay.
If you have some minutes left, there is one more question.
Yes.
The same participant of before said, can I do the property analysis like stress strain with those softwares?
Of course. If you work with topology optimization, you set a limit in advance. You say the stress at any intersection should not exceed, let's say, 150 Newton per square millimeter. Yes, you can set a limit, and then the proposal of the topology optimization software respects this limit. Yes, and but finally, if you go closer to the borders and to the limits, you always can feed in your construction, your output of the topology optimization. You put it into as an input into the FEM, and then you also get the results and know at which corners, at which places of the part there is maybe some critical stress.
Okay, thank you. 1 minute left, so one more quick question. Have you ever seen a rod-based manufacturing method for optimized lattices?
A what based?
Rod-based.
Yes, a rod-based.
Rod-based manufacturing method for optimized lattices.
I really cannot get the question. A rod is, please, Mr. Zwantschko, help me. A rod is a Stange in German.
Yeah, I think so.
A rod and a rod-based part. Maybe maybe the person means there's eine Fachwerkkonstruktion, meint eine, so wie Krankonstruktionen. Could you give maybe
maybe Mr. Nicolas can explain a bit the question in the chat,
Yes,
or
yes.
get some more details?
He's saying metallic wire,
Yes.
basically.
Maybe he works with a wired based with a wired based additive manufacturing device.
A metallic wire, basically, he wrote, yes.
Yeah, he confirms.
Okay, this machine is because we have to differ between different technologies in additive manufacturing. You have a powder bed fusion, you have a wired based, there's so many, you have laser cladding, there's so many different technologies. I assume the participant now means that yes, that he has a wired based additive manufacturing. Of course, it can build lattice structures, but in a much more rough way. The examples I brought are only possible with powder bed fusion, I would think. But it is always first you have to create a design, and you have also to interconnect. Is it with which means of additive manufacturing is this very design producible? Yes, and not any design can be produced with any technology of additive manufacturing. Yes, this remains the same as in old days. What you design must always be in connection. You have to mind the producibility. The capabilities have grown, have become much bigger now. This is what I presented, but in detail you must look. Maybe I invite this person to be to send me an email and to be more precise, and then we have a bi-directional conversation. Is this an option?
Yeah, because he wrote in the chat the same thing.
Maybe he could give me also an example. He can send me designs and whatever. Yes, please.
Okay.
I'm awaiting your email, Mr. or Mrs. XYZ.
Okay, perfect. Yeah, we will share your email with the participants so that they can write down some more questions. There are actually some more questions, but I think you have to leave now. So
bring it to me via email. But I'm really in a hurry now. Thank you for the possibility. Have a good day and a good session.
You too. Thank you. Bye. Bye. Okay, so now let's switch to the next presentation from Miriam García from Lortek. She will talk about the advances in metal additive manufacturing, providing some real-world use cases to exemplify the potential benefits of additive manufacturing, both from a production point of view and a business point of view. So please, Miriam, let's start.
Thank you very much, Miriam. I will share my screen. Okay, so start with the presentation. So as Miriam already introduced, I'm going to talk about some use cases. So my presentation is focused on providing some examples of the use cases that we have carried out in Lortek in the framework of different projects and together with different industrial partners. So I hope that this can inspire you a little bit in order to propose new research projects or innovation projects in the additive manufacturing field. So SMEs and industrial companies have to face different challenges in order to adopt the additive manufacturing within their processes. So the most common challenges to face are these ones that we are indicating here. So the lightning, so that was the focus of my previous presenter. Okay, so the reduction of the weight. But there are other challenges such as the increase in functionality or the performance, also to deal with repairing activities and the production of spare parts, trying to reduce also the use of material and the waste, and the provision of flexible manufacturing in terms of customization. So in order to answer to all these challenges in Lortek, we work with different technologies, as those you can see here. So we are working on new design concepts in the sense that Rudolf explained in the previous presentation, so working with topology optimization and generative design. Also working with simulation activities in order to ensure non-defectiveness of the parts, with process optimization, with digitalization, with new materials, and with the industrialization of the technologies, of the processes. So with all this in mind, I will show you 7 examples of real use cases that we have carried out. And all these use cases will be related to some of these challenges that I'm showing you here. So the first one actually is something very similar to what the previous presenter explained about the hydraulic block. This is the reality of the real use case of what he showed before. So here the aim was the lightening, the reduction of the weight. These hydraulic blocks are used in industry and in the energy sector. And we have an SME, a Spanish SME called INE, which wanted to optimize the design in order to reduce the weight, but they needed to keep the same functionality, obviously. So we worked on the topology optimization, as he explained before, in order to optimize this new design according to an optimized functionality and manufacturability by laser powder bed fusion. So we obtained a reduction of 71% of the weight, which is a very good solution, very good results, keeping the same functionality. So the company was able to include this new product within their catalog. So the second use case is a flow control actuator for aeronautics. Here, the aim was to increase the functionality. So Airbus had a very good design, okay, of this flow control actuator in order to improve the fluid flow of the future engines that are going to be used in the future aircraft, but they couldn't manufacture by any other means except for additive manufacturing. So they were looking for someone to be able to manufacture some prototypes with these new designs. So we work on simulation of the laser powder bed fusion process. We optimize also the manufacturing parameters to avoid defect, and we obtain this prototype that you are seeing here in the picture, which is a flow control actuator with a very, very complex design. Actually, we had to face many problems. For example, the powder was stuck inside the internal channels. So we had to be very imaginative in order to create solutions to take out this powder before making the thermal treatments of the parts, okay, in order to have full functionality of the parts. Actually, Airbus was very happy with the results. Then we have another use case, which is a manual electric hydraulic tool. In this case, Alcar, which is a Spanish SME, was looking for lightening and increase of the performance of the part. So they wanted to change the design and do something. The problem was they wanted to do something to reduce the weight and improve the usability of the head of the tool, of this tool that you are seeing here. So we optimized the design in terms of performance and manufacturability by additive manufacturing, by laser powder fusion specifically, and we manufactured the prototypes. So in the picture, you can see what we did in terms of optimizing the design and the final result of the demonstrator. So we obtained a reduction of the weight of 25% with very good technical performance. We were able to reduce the size of the tool, and the ergonomy was improved for the users. So Alcar has included this new product in the product portfolio. And the fourth use case, it's a sealing ring. And here the aim is to substitute toxic materials. It's used in aeronautics. So Liebherr wanted to substitute its cobalt alloys that are nowadays used in these sealing rings, but have health potential issues in the cabin air. So they might be toxic for the pilots in the aircraft. So they wanted to substitute these cobalt alloys and the manufacturing of the sealing rings by other materials. So we selected some alternative materials and optimized. In this case, it's a laser-based DED process. We're using powder, using different monitoring systems. So we were able to manufacture these alloys, these sealing rings, solid, that you can see in the picture, using nickel alloys, having almost practically the same performance as the actual cobalt alloys in terms of high temperature wear resistance. They were lighter as well, and they had less toxicity than these cobalt sealing rings. So Liebherr has found a very good solution, and actually they are going to continue working in this sense in order to try to produce this at higher TRLs. The next use case is a heat exchanger for aeronautics. Here, the aim is to increase the performance. They wanted to improve actually Safran was the company behind this, and they wanted to improve the aerothermal properties of the heat exchangers. And for that, they wanted to reduce the wall thickness of the fins. So they had some specific designs of the heat exchangers to be manufactured by additive manufacturing, but they wanted to reduce the fins because this would bring a major improvement in terms of aerothermal performance. So we developed different manufacturing strategies for laser powder fusion in order to reduce this wall thickness in two materials, Inconel 718 and an aluminum alloy. And actually, the the results were really amazing because we were able to reduce the thickness below the state of the art. We manufacture wall fins with a thickness below 0.2 millimeters for both materials. So it's a really good result because they are really thin. And with this, then we manufacture real scale heat exchangers. We tested them, we also simulated them, and we got that the aerothermal performance was increased above 15% while keeping the same mechanical properties. Then the sixth use case is an aeronautic component with sensing capabilities. So here, it's something different. Here, what we wanted to improve was the functionality of the parts. So Aerotechnic, which is an SME as well, they wanted to include optic sensors within different parts for the aircraft in order to make structural health monitoring of the parts. So we developed a system to embed some metal-coated optical fibers in aluminum structures using WAM technology, wire arc additive manufacturing. And we found out that the resulting part had the capacity to measure the temperature and the strain within the parts. So what we really wanted to achieve. We made a demonstrator, which is this bulkhead panel that you can see. Maybe it's not too appealing. Obviously, we had to continue working on this. But it's a way to demonstrate for Aerotechnic, it was a way to demonstrate that it's possible to manufacture and to obtain parts with sensors inside the metal that can be used for structural health monitoring. So it's a step forward in these new aircraft that are willing to obtain. And the last use case is to show you how additive manufacturing can be applied on wind farm components. In this case, the challenge to face is double-fold. So on one hand, we have the lightening, and the other one, the repairing. So the challenge was to redesign and to repair these gears, okay, which are part of the planetary gearbox of the windmills. Okay, so we applied topology optimization to the design in order to ensure that we could manufacture by laser powder bed fusion, as you can see in the picture on the left. Okay, you can see there the process. Then we manufacture these gears, and we made on purpose some fails in two of the teeth in order to check that we were able to repair them. Okay, so we repaired these two teeth using DD technologies, laser-based DD technologies, where we had to optimize the path planning trajectories. You can see this in the picture on the right with the yellow square. Okay, these are the repair teeth. So the results were really good because we were able to reduce the weight of the part by 37%, also the manufacturing time by 25%. And regarding the repairing, we were able to repair each tooth in 1 minute or even less than 1 minute without any need for post-processing, so as it is, which is a huge advantage, and with an efficiency in the deposited material of 90%. Okay, so it's a very good result to demonstrate the possibility that additive manufacturing can make in this kind of components. So with all these use cases, what I wanted to let you know is that additive manufacturing can do a lot for SMEs. At production level, additive manufacturing is able to produce prototypes of new products, customize small batches, reduce lead times, reduce the waste, enable complex geometries, help you on demand manufacturing, and even help you on producing rapid tooling that can be set up in traditional manufacturing, just for jigs, fixtures, tools, and so on. And all these benefits in the production level can be translated to the business level, because additive manufacturing can help you in differentiating from competing products, because it enables this better performance, lighter weight, and so on. Also a market advantage, because you can make new products or quicker manufacturing. as you have seen in some of the examples. You can reach also new customers because we are offering innovative products, as some of the SMEs I mentioned made, including the new products in their catalogs for new customers, access to niche markets and meet specific customer demands, and even cost savings in two ways. On one hand, because it produces less waste and needs use of less material, but also because it turns out in reduction of storage costs. So now I hope that you can think on new projects dealing with additive manufacturing, and on this regard, the SURE5.0 project can help you a lot. And just to finalize, I want to mention that we are part of the service provider of the project. So we are offering different services, specifically service 2 and 6 are focused on additive manufacturing. So we can help you on designing the products, on qualifying the processes and the products, in prototyping, validation, helping you in what you need to industrialize the process, and even in training, okay, for metal additive manufacturing. So if you need any support on your new metal additive project, you just count on us, okay? Here is my email, so you can write to me directly. So that's all, and thank you for your attention.
Thank you, Miriam, for your interesting presentation. I think these use cases and examples are really fundamental to empower SMEs to make informed decisions and to embrace additive manufacturing technology as a real strategic advantage. So now let's open the final Q&A session. So if there are some questions, both for Miriam García and for Michael Zwantschko, let's write them into the chat again. While we are waiting for possible questions, I'll remind to all the participants that the recording of this webinar will be available on SURE5.0 project website. So sureproject.eu is the URL of the website, and it will be available, I think, between today and tomorrow. Okay, here there is one question. How do we participate in the SURE5.0 upcoming projects? So, Michael, if you want to explain the next steps.
Yes, sure. If you want to participate, please check out our website. There's all the information necessary you need for applying for the acceleration program 2. On the upper side of the website, there's a button called Open Call, and if you select acceleration program 2, there's mentioned how to apply and also the timeline of the open call. As mentioned, the open call is open till end of February next year with 3 cutoff dates, and it's a first come first serve principle. So we have the 25th of October, the first cutoff, then the 3rd of January and the 28th of February next year. So please check out how to apply. As mentioned, the first step is go to the self-assessment, do the questionnaire, and then make the second step to register on the application platform, which is provided by F6S, but all the links are on the website. Fill out the technical annex and the question which are mentioned there, and then you have the chance to apply for the second acceleration program, which is divided in 2 phases. If you are selected, then you are part of the first phase, where you get the first services and in-kind assessments and so on, which are providing by the consortium, which helps you to identify the project you want to apply for the second phase.
Okay, thank you very much. Let's see if there are some more questions. Okay.
Maybe I can raise a question if it's okay to Miriam.
Yeah,
So what is
sure.
what is the potential of advanced additive manufacturing if you look to mass production parts? Because we were talking about the construction parts or for aeroplanes or something. But if you look to maybe mass production parts, or is it when it become cost effective, and what is the potential for it?
Well, what we have seen, according to our experience, is that maybe depending on the technology that you are using. So if you are using laser powder refusion, for example, which takes quite a long time and so on, maybe it's not specifically for serial production. But if you go for other type of technologies, more focused on DD technologies, for example, LMD, WAM technologies, they are able to produce quicker, much quicker. So in this case, it could be for a serial production, obviously for not every product. So you have to select maybe some products that that could be quite difficult to achieve by traditional parts, even in a serial production, but they have some kind of complication, or that you produce a lot of waste during the manufacturing of those parts and so on. So in such cases, these DD technologies can make an advantage in terms of productivity. Yeah.
Okay, thank you. In the meanwhile, the direct link to access the acceleration program of SURE 5.0 was shared in the chat, so SMEs interested in deepening this topic can directly go there. One more question. Could you please share more on how the embedding of optical sensor done at the wings through DED or LPBF?
Yeah, we did it through DED technologies. So we're using WAM technology, wire arc additive manufacturing. It was for a big part. So first of all, we had to develop, not ourselves, but another partner of the project, created the coatings of the optical fibers, okay, in order to withstand the aluminum temperatures, okay, because this was a key problem when embedding the optical fibers. So then we embedded in two ways. So we made small channels in some of the of the bars, okay. So we made the small channels, introduce the optical fiber and continue producing. So this was one of the methods. And then we produced another method which was directly. So we were putting the wire in the part, so including increasing the height. And in some point, we made a mechanism to put such an optical fiber and continue producing in continuous. So in both ways. So we stopped, made some channel and introduced the optical fiber and continue producing, and in a continuing way as well. But always using WAM technology.
Thank you. Any other question? I can't see more questions, so if there are no more questions, we can close here the meeting. And so I invite everybody to follow all the information on SURE 5.0 website, and also to follow us on social media, so LinkedIn and Twitter accounts, so that you can keep informed about all the initiatives and all the next webinars we will organize. Thank you very much. There is a last question. DED melting temperature won't damage the optical sensor.
This is what I said, that we work with a Polish SME, and they produce a coating for the optical fibers in order to avoid the destruction of the optical fiber when we were integrating in the WAM process. So this coating withstands the melting temperatures of the aluminum. But it's necessary to work in two fields, so the additive manufacturing and the coating of the optical fibers. But there are already companies working on this.
Thank you. So if there are no more questions, I think now we can close the session. Thank you very much. Thanks to our speakers and to all the participants. I think it was a very useful moment for sharing precious insights for innovation path in European SMEs. And so let's see for the next webinar. Bye. Bye-bye to everybody.
Bye.